Hey everyone, today is Friday. Yay! We're so excited about that. That's the day we've been waiting for all week. The weekend's coming, so we're pretty excited about that, and we're getting ready for the next week where we will all brick and mortar students will be at school. So I'm excited to see everyone's smiling faces, and I can't wait. But for today, we are still all virtual, and today is Friday, February the 26th, 2021. We are still working on calculating elapsed time, and we're going to continue doing that today. You're going to be watching this video, and then you're going to complete the problem of the day and complete the assignment that I listed on Google Classroom. So let's go ahead and get started with this lesson. And again, we're just going to kind of review that we are calculating elapsed time. We know that elapsed time is the amount of time that has passed from the beginning time to an end time, and that we can find elapsed time by counting the hours and then the minutes. So we're going to be thinking about that as we work through on a number line. So let's jump right into the first example. And the first example says that Jill travels from Louisville, Kentucky to St. Louis, Missouri each week. She leaves her house at 5 a.m. If it takes her 4 hours and 27 minutes to get from Louisville to St. Louis, what time did she arrive? What time did she arrive? So let's think about what we know from this problem. So what do we know for sure? We know that Jill is traveling, and we know that she leaves the house at 5 a.m. It takes her 4 hours and 27 minutes to get from Louisville to St. Louis. We don't know what time she arrived, so that's what we're going to be calculating. So I decided to try something a little different today. Today we're going to use that number line that we've used in the past. Now it will not let me put colons in between the hours and the minutes on our time, but I'm going to go ahead and just put a space there, and then when we go over to get our marker that we can use to draw on it, then we'll put those colons in. But for now I'm just going to put a space between them. So let's think about what we know again. We know that she left at 5 a.m. and we also know that she drove for 4 hours and 27 minutes. So on this number line, we've got to think about how we're going to place those numbers. Now, in this particular problem, we know her start time. So I'm going to go over to the beginning of the number line, and I'm going to go ahead and put her start time there. And she left at 5, and then I'm going to put a space, because remember we talked about that. I don't have the colon there to put, so I'll do that at a later time. But we know that she left at 5 a.m. and it took her 4 hours and 27 minutes. Now remember, we talked about how we can represent those hops by mountains, hills, and rocks. And we're going to first decide, do we have hours that we can jump? Now, according to the problem, it said that she traveled 4 hours and 27 minutes. So we actually have 4 hours. And we're going to be able to use 4 mountains in this problem. So I'm going to go ahead and draw me, not very good ones, draw me some mountains. And again, we can draw 4. So I'm going to go ahead and draw 4 mountains. And then we're going to decide what time it is in 4 hours. So I'm going to come down here and get me some boxes to type in. So we're going to decide what is 1 hour from 5 o'clock. So I'm going to do 6, and again I'm going to put a space to get those spaces for my colon, and then I'm going to do another hour, and again we're going to think about what hour is it going to be from 6 o'clock, and we know that's going to be 7. And then I'm going to decide again what hour is it going to be in an hour from 7, and that's going to be 8. And then another hour is going to be 9. Okay, now we're thinking about minutes. First of all, can we go another hour? So we've decided that we can't because we knew we only had 4 hours. Now we're going to be thinking about the minutes. And remember that hills represent 5 or 10 minutes, and then the rocks represent 1 minute. So we're going to decide if we can hop with using heels. So at this point we have 27 minutes, And most of us know that who passed their tens know that 2 times 10 equals 20, so I can get 2 10 minutes in this problem. So now I'm going to represent those by heels. Okay, so I'm going to come up here and I'm going to get my drawing tool again, and I'm going to draw heels this time. And if I go 10 minutes, I know that I can type in here. Let me get rid of my drawing tool and let's just use typing. So I know that I can type in here 9 and 10 minutes. It would be 10 minutes after 9, so I'm going to put my space in 10 minutes. And then if I add 10 more minutes to that, it's going to be 9:20. So at this point we've used 4 hours and 20 minutes. That leaves us 7 minutes. Now we could do this part differently, and I have had in class, some people do it differently, but for me, I think I want to get rid of all of the hours, tens, and fives that I can. So in 7 minutes, I know that I can get a 5 minutes. So I'm going to go ahead and put up another square and pull it over here, and I'm going to go ahead and add 5 minutes to 9:20 to get 9:25. Now that only leaves us 2 minutes. So if we only have 2 minutes left, oops, it's not drawing there for me. If we only have 2 minutes left, then I can do that with rocks, and I'm going to go ahead and draw my rocks so I don't have to get this drawing tool back out. Remember, rocks are rounded at the top. And then I'm going to go ahead and get rid of that so I can put my boxes back up there. And on this box, I know that I'm adding 1 minute each for the 2 minutes that are left. So 1 minute after 9:25 is 9:26, and 1 minute after 9:26 is 9:27. So I'm not even going to worry about drawing those marks on there because we know that that space means that colon. So again, the mountains represent hours, so I have 4 hours, and the hills represent 5 or 10 minutes, and I have 2 10 minutes, which is 20, a 5 minute, which is 25, and then 2 minutes, 1 minute each, which equals 2. So again, we are thinking about how those are represented there. So in this problem, I can see that I've used all of the time that had elapsed, and that my end time is going to be 9:27. Now remember, we restate the question when we're answering this problem. Now all this work shows my thinking process here, but the final sentence summarizes everything that was done. So we're going to say that it takes Jill drives from Louisville to St. Louis and will arrive at 9:27 a.m. Now remember, we are still in the a.m. here because the original problem said that she left at 5 a.m. and we have not come to that noon point to change over to p.m. here. Okay, so you could also say, because I now can see the question, which makes it a little easier, we can say that Jill arrived in St. Louis at 9:27 a.m. So let's look at another example. In this example, we have Cameron and Lucas who are going to the movies. So Cameron and Lucas go to the movies at 5:15 p.m. The movie lasts for 2 hours and 25 minutes. What time did they get out of the movies? Now let's think about what we know. We know that Cameron and Lucas were going to the movies. We know that the movie starts at 5:15 p.m. We also know that the movie lasts 2 hours and 25 minutes. The only thing that we don't know is when the movie ends, or when they're going to get out of the movie. So let's hop over to our number line and let's do this problem the same way that we did problem number 1. So as you can see, I've already got my number line started. Remember, I'm just going to put those spaces there just to save time instead of having to draw those in. But the movie started at 5:15 p.m. The movie lasted for 2 hours and 25 minutes. So we're going to start thinking about, do I have hours to get rid of first? And we do, so I'm going to draw those mountains for that to get rid of those. I actually have 2 hours, so I'm going to draw 2 mountains. Go ahead and get those drawn. And those are going to represent 1 hour. And I forgot to label those on the last problem, but you know that the mountains represent 1 hour because we've been doing that for a little over a week. So we already know that mountains are an hour. The next one's going to be the minutes now. We have no more hours to hop, but we're going to go ahead and put what each hour, hopping up each hour, represents here. Now, remember that only the hour is changing here because we are not dealing with the minutes yet. So my minutes are going to stay the same. So an hour after 5:15 p.m. is 6:15 p.m. And then we're going to do another hour because we hopped 2, and we're going to think about what is the hour after 6:15 p.m. and the hour is 7. And remember again that the minutes aren't changing here, so it's 7:15. Now we're ready to start thinking about those minutes. And again, we're going to think about those minutes in heels, trying to get rid of any 5 or 10 minutes that we have. And according to the problem, we have 25 minutes. Now, most of us know that we can break that 25 down into 2 10s and a 5. So that's what we're going to do in this problem. I'm going to go ahead and put me some boxes up here to go ahead and get rid of those minutes, and I know I'm going to represent those minutes with heels, so I'm going to go ahead and draw me some heels here. And remember, we're going to think about what we're drawing. Those heels can represent 5 or 10. Oops, so I would go ahead and label those. That's a bad heel. I would go ahead and label those by the minutes that I'm using, so I'm going to put 10 and just an M. So the first two is going to represent 10 minutes. And then the last one is going to represent the 5 minutes to get us our full 25 minutes. And we're going to start adding that to our number line now. So if I add 10 minutes on to 7:15, is my hour changing? I hope you said no, because it didn't change at this point. It's going to stay the same, but my minutes are going to change. So we're going to add 10 minutes on to 15, and we know that 15 plus 10 equals 25 minutes. And then we're going to go over here and we're going to do the same. Again, my hour doesn't change, so I still have 7. And I'm going to add 10 minutes on to 7:25, and we all know that 25 plus 10 is 35. And then I'm going to go to this one and I'm going to add only 5 minutes. So my hour doesn't change again because I haven't passed that 60 minutes yet. And then I'm going to add 5 to 35 to get 40. So in this particular problem that we just did, Lucas and Cameron had gone to the movies. The movie started at 5. It lasted 2 hours and 25 minutes, and we were looking to see when the movie ended. So my final summarizing statement that I'm going to say for this problem is the movie ended at 7:40 p.m. 7:40 p.m. Now remember, it's really important to put a.m. or p.m. so we know what time of the day this was taking place. I want to quickly remind you that on the virtual manipulative slide that you can use for these problems, you can find that particular number line here to help you on those problems. Now, I do want to mention also that when you're looking at an analog clock like you're going to be on your assignment today, you can count by 5s and 10s on there to help you. So remember to think about that as you're using that clock. Remember, a clock is just a number line put in a circle. So it's the same as what we were just doing on that horizontal number line. You can use that circled number line to count just the same way. So you can use your number line to help you hop. You can count forward or backward on that analog clock. So use all the tools necessary to make you feel successful on that assignment today and help you through it so that you can be successful. I hope everybody has a great day, and my secret word for today is Friday. Yay, it's Friday. So that's the secret word on the lesson work. Put Friday. And I hope everybody has a great weekend. Look forward to seeing you on your multiplication test from 12 to 1. See you guys later.